Hello, I'm back. Okay, so what are we going to do today? So today our focus is on acid, base and salt. Okay, we are going to do section 6.3, which is strength of acid and alkali. Okay, so the moment I say strength of acid or alkali, you must understand what is an acid and what is an alkali. An acid, okay, consists of free moving hydrogen ions, and alkali consists of free moving hydroxide ions. So what are we going to do? We are going to talk about how to measure the strength of an acid. Okay, and then we are going to classify the acid into two different types: strong acid, weak acid, and also examples of strong and weak acid. Okay, then we are going to move to our alkali. We're going to talk about strength of the alkali, how do we measure it, and we're going to talk about strong alkali, weak alkali, as well as examples of strong and weak alkali. Okay, so for the first part, let's talk about strong acid. Okay, but before that, how do you measure a strength of the acid? So strength of acid is determined by the degree of ionization or dissociation of the acid in water. Okay, so the degree of ionization or dissociation of acid in water is something is very important, okay, in chemistry. Okay, it tells us the strength of an acid. If an acid ionizes completely, the word is completely in water, okay, to produce a very high concentration of hydrogen or hydroxonium ion, you call it a strong acid. Okay, complete ionization and high concentration of hydrogen or hydroxonium ion. Example, hydrochloric acid. Okay, when you dissolve hydrochloric acid in water, you will have hydrogen ions and chloride ions. So this is aqueous, this is also aqueous, this is also aqueous. Okay, so complete ionization and high concentration. None of the hydrochloric acid here will exist in the form of molecules. Everything will be free moving ions. Okay, once you have this high concentration of hydrogen ion, you call it a strong acid. But these hydrogen ions, okay, can form a bond. Okay, the moment hydrogen, okay, is in contact with water, water has got two lone pairs of electrons. Lone pair is always dative bond. Okay, so a dative bonding takes place down here. Can you see not? So the two electrons is given to the hydrogen, okay, given to the hydrogen, and you have a positive charge. So this is the formula of hydroxonium ion, which is the same as hydrogen ion, but this is hydrogen ion that has formed a dative bond with a molecule of water. If you have nitric acid, this acid also undergoes complete ionization to give you hydrogen ions and chloride ions. If you have sulfuric acid, you have 2H plus and SO4 2 minus sulfate. Okay, if you look at the difference between this and this, you remember basicity. So sulfuric acid and nitric acid and sulfuric acid, they have different basicity. This is a monoprotic acid. Okay, if this is a monoprotic acid, what do you think? 1 mole gives you 1 mole of hydrogen. 1 mole gives you 2 mole. This is a diprotic acid. So which acid do you think is a much stronger acid? Okay, think about it. Okay, 1 mole of the acid gives you 2 moles of the hydrogen ion. So of course the sulfuric acid is definitely stronger than the nitric acid. So this is an example of a monoprotic acid. This is an example of a diprotic acid. Okay, so when we say you are strong acid, complete ionization, high concentration of hydrogen or hydroxonium ion, none of these acids exist in a molecule form. Okay, don't forget, hydroxonium is formed when the hydrogen reacts with a form of dative bond with water. Okay, what about weak acid? Okay, so what about weak acid? So when I say weak acid, it ionizes partially in water. Partial ionization. So we have a low concentration of hydrogen ions or hydroxonium ions. Okay, there's one example here, which is ethanoic acid. Ethanoic acid. Okay, ethanoic acid, okay, undergoes partial ionization. Can you see the reversible reaction here? Okay, it produces CH3COO minus plus H plus. Okay, this is your free moving hydrogen ions. Okay, this one is the ethanoate ion. Okay, this is the ethanoate ion. Can you see? So when you have ethanoic acid, you dissolve it in water, you have free moving hydrogen ions as well as ethanoate ion. The presence of the free moving hydrogen ions give acidic property. But you must remember, this is reversible reaction. So these hydrogen ions can combine again with the ethanoate ion to form the molecule. So the arrow is more onto this side. Okay, the equilibrium is more onto this side. So because of that, you have a very low concentration of hydrogen ion. So since you have a low concentration of hydrogen ion, you call this a weak acid. A weak acid, partial ionization, low concentration of hydrogen ions. Okay, for information, okay, when you talk about ethanoic acid, the degree of ionization of ethanoic acid is 1.54% only. So for every 100 molecules of ethanoic acid, okay, only one molecule ionizes to form hydrogen ions, okay, and ethanoic ions. So you can see that this is a very weak acid, okay. So we have learned strong acid, weak acid, okay. So what can we tell about strong acid and weak acid? Okay, so if you're a strong acid, what about your degree of ionization? What's the word that shall I use? I shall use the word complete ionization. Here, I'm going to use complete ionization. Okay, you don't like ionization, you can use the word dissociation. What about weak acid? What shall I use? I will say this one undergoes partial ionization. Okay, degree of ionization. What about the concentration of hydrogen ions? So this one has a high concentration of hydrogen ions. What about this one? This one has a low concentration of hydrogen ions. Okay, what about the pH value? Okay, don't forget your pH value. This is your 7, this is your 0. So if I say strong acid, you are around here. So your pH value, is it lower? So pH value lower. It's around 0 and 1. Okay, what about this one? Weak acid. So weak acid is around here. Okay, so what is your pH value? Your pH value is higher. Okay, do you notice? So I can have a pH value of 4, 5, okay? So I'm a weak acid, okay? I can have pH value of 4 and 5, okay? So once we have covered acid, let's move on to our alkali. Okay, so we can classify your alkali into strong and also weak alkali using the same concept. Okay, what can we say? Okay, if you're a strong alkali, you undergo complete ionization when dissolved in water, okay, to produce how? What shall we say? To produce a high concentration of hydroxide ions. Okay, hydroxide ions. What about this side? Okay, this one is complete. So this one will be partial. Okay, partial ionization or dissociation when dissolved in water. Okay, in water to produce a low concentration of hydroxide ions. What about examples? Okay, examples, I can have sodium hydroxide. Okay, so I can take a solid sodium hydroxide. Okay, I can dissolve it in water. When I dissolve it in water, I will have free moving sodium ions and hydroxide ions. So the more hydroxide ions you have, you are a stronger alkali. What about this weak alkali? I can take ammonia. Okay, I can dissolve it in water. This ammonia gas, dissolve it in water, undergoes partial ionization to give you ammonium ions and hydroxide ions. The moment you see the reversible reaction, it goes to show ionization takes place and then it combines back again to form. This whole thing is known as ammonia solution. An ammonia solution contains a very low concentration of hydroxide ions. The degree of ionization is about 1.3, so the same thing. So if I have 100 molecules of ammonia aqueous, so I will get how many molecules will ionize? Only one molecule will ionize. Ionizes in water, trying to tell you that it's a very weak alkali. So this is a strong alkali, this is a weak alkali. Okay, so the difference is the degree of ionization. The keywords are complete, partial, high, low. Okay, what about the comparison? Okay, so let's compare. So if you're a strong alkali, what was the keyword? Complete ionization in water. What about this? We have the keyword will be partial ionization in water. Okay, what about the concentration here? So the concentration of the OH minus must be high. What about this? The concentration of the OH minus must be low. Okay, what about the pH? This is 7, this is 14. So the high one will have a what? Higher pH value. This one has a higher pH value. Around where? It's around here. It's around 13 and 14. What about this one? This one has a lower pH value. So you can have a pH value of around 9, okay, 8, okay, 10, okay. So this one is lower pH value because partial ionization and the concentration of the hydroxide ions is very low. So what have we covered? We have talked about strong acid, weak acid, strong alkali, and weak alkali. Okay, read through your work and try to do some questions on strong alkali and weak alkali. Thank you.